Welcome. So, in this session, we are going to continue what we started on hyperparameter tuning. And this particular session is going to be covering randomized search. So, um, in the last one, we looked at grid search, and I explained that grid search will search through all of our all of the combination of hyperparameters that we specify in our parameter grid. So we saw that, for example, in this particular one, we did 380 fits, that is, we trained 380 different models, and this number 380 came from the number of criterion that we have in our parameter grid, which is one, two, three, four different criterion, and the number of max depth that we have, which is about 19, which is 19 actually. So 4 times 19, that gives 76. And then for each of our food, each of the splits that we have, so 76 times 5, that makes it 380. So it means if we have something bigger than this, we are going to have even like a much larger number, because in grid search, we're going to search through every single thing, like every single combination of hyperparameters will be evaluated. And that's what makes it computationally expensive. Grid search, compared to other ways of doing hyperparameter tuning, is very, very computationally expensive. So, but although it guarantees that you find that you're going to find the best parameters within that particular grid. Now, however, sometimes this is not a good deal, right? So sometimes you don't have that much compute, you don't have that much time, so you just want to quickly blow through the search. You want to just get something out as quickly as possible, and that's where randomized search comes in. So randomized search uses this approach where instead of searching through the entire space, we search through a tiny subset of it, like a sample within that parameter grid. And that sample is going to be defined by a parameter called number of iteration n iter. So here's what I'm going to do. We're going to be working with the exact same data set. So I might as well just come here and click on run all, so that we run everything, and our food remains the same. The parameter grid, we are going to define a new one, or even make this bigger. Okay, we have an error. It says care food is not defined. Yeah, that is because we set up cross validation later. So instead of just doing CV equals careful, let's just do CV equals 5 instead of moving things around. So CV equals 5. Right. So we can then run. That is still going. Right. So we can get our best params and best grid estimator, and then this. Yeah, another thing we could do is we could probably play around with a different instead of using decision trees, right? Maybe play around with a different base model, or we could look at, I want us to expand that particular one. So for example, we could have mean sample split is 2. So we could probably play around with different mean sample split, or one of these guys here, or we could change it if we want. So I'm going to come here, and so since we have access to all of these things, I can come here and say um, we're going to be using the same parameter grid. So if I say param, just to print it out, parameter underscore grid. So it's still this same grid of criterion equals this, max depth equals all of this. Now, how does randomized search works? So the way randomized search works is to come here and say set up randomized search tuning. And the first thing that we're going to do is choose our number of iterations. So I'm going to say no of iter, and that's going to be 50. Then we can come here and say randomized randomized is going to be equals to, you can name it anything that you want, randomized search CV. And the first parameter that goes into, okay, we don't have randomized search yet, so you can import it if we want here at the top. You can say from scikit-learn.model selection import randomized search CV. So when we do this now, the first thing that we pass in is our estimator, and our estimator is going to be the regressor as usual. And don't forget, we are not really writing this whole thing from scratch. We are continuing from where we stopped in the last class. So the regressor is the one we created. Let me actually clear this off. The regressor is the one we, instantiated here. Great. So the next thing we want to do is we want to come in here and say comma. The next argument that we pass in is param distribution. So in this case, it is called param distribution. In grid search, it is called param grid. When randomized search, it is called param distribution. So we say that is equal to parameter underscore grid. The next thing is n underscore iter. How many iterations do we want this thing to run for? So we want it to run for 50, which is what we've defined at the top, number of iter, which is 50 here. Then we're going to say scoring. Do we have scoring? Yeah. So scoring is going to be equals to negative root mean squared error. And then we can have random state. Now this uses random state because it is not using, the tuning is not using all of the parameter grid. All of the combination in the parameter grid is only going to randomly sample. So we want it to not, we want to be able to reproduce it. So if you don't pass in random states, you are going to lose the ability to reproduce. Then we can say variables equals 3, CV equals kf underscore fold dot split. I don't know what we are splitting. I guess x underscore train underscore transformed. Yeah, and we can say return train score equals true if you want to see. You're interested in seeing your train score. Yeah, that's cool. So we can come and say randomized dot fit x underscore train underscore transformed, comma y underscore train. So if we run this, unless there's an error, so it has started training. Now the important thing is this. The important thing is, now this is done. So you're going to see that we use the same parameter grid that we used in grid search. But in this case, in grid search, we fitted how many? We fitted 380. In grid search, we trained 380 different models because the combination of hyperparameter was 76. But in this case, we don't want to look at all 76, probably because we don't have time and stuff like that. So we just tell it, take only 50 out of those 76 and train it. So it goes 50 multiplied by each fold, which is 5. That is the fold here, and it totals to 250. And that is how randomized search works. But the problem with randomized search is that it is going to sample out the combination of hyperparameters that matches your number of items before the training even begins. So it's kind of like a simple random sampling kind of thing, and you your probability of finding the right thing. For example, in this case, the probability that this particular, if I come here and I say randomized dot best params. Now, if I should go for model dot best params, that is this for grid search. I think we named grid search model. Oh, it's best grid. No, grid model. We named it grid model. So grid model, grid that's model dot best params. Now, if you look at this now, uh, the best parameters, like overall, the overall best parameter is criterion equals squared error, max depth equals 3. But in the case of randomized search, it got max depth equals 3, but criterion equals Friedman MAC. That's because this guy here, this grid model here, grid search, actually compares every single position, like every single combination of hyperparameters, compare them. Do you understand? But this guy did not compare them. It only worked with 50. So the probability that your randomized best parameters, like this, best parameters you find from randomized search, the probability that it is the global one within that parameter grid that you define is actually, in our case here, 50 divided by 76, which is so it's 0.65 probability, right? Because we only randomly sampled 50 of 76, right? Yeah, so and that is going to be evident in, if we say randomized dot best score. So we can actually negative that. That is 1.123. And if we do grade underscore model dot best score and we run that, so we see yeah, they're fairly close. They are fairly close. I think they are even almost the same thing, right? So, but in general, and that means that what this tells us is that criterion is not really a major contributor to this thing, because that's the only thing that changed. Max depth of 3 is the same, and the difference in criterion did not actually like lead to any difference in um the model performance. So, but in some cases, in like most cases, general cases, you're going to find that the results that you get from grid model is going to be way better. The result from using grid search is going to be way better than randomized search. But randomized search is way faster. Not faster in terms of the fact that it's a much more efficient algorithm. Faster in the sense that we are not considering every combination of hyperparameters. We are only considering the ones that we specify inside number of iteration. So let's say you have a grid that totals to, let's say, 500, and you are only getting out, you are say then you say your number of iteration is 100. So the chance of the chance of finding the best hyperparameter in that case is going to be 1 over 5, right? So it means you have just 0.2 chance. So that is randomized search for you, and it is limited in types in terms of its ability to find the best parameter. It is extremely random, extremely probabilistic, but then it is very, very fast, and just gets us something better than the base model, quicker than grid search would. So yeah, that is um randomized search. In the next one, we are going to be looking at Bayesian optimization with Optuna. So thank you. See you in the next one.